Hello everyone, and welcome to the functions lecture. So in this lecture we're going to be learning about functions and getting our first introduction on how to actually make our own functions. So we've seen a few functions in the past, such as len, remember that length function, and now we're going to learn how to build our own functions. So let's go ahead and get started with a quick introduction to functions. So what are functions? So formally speaking, a function is a useful device that groups together a set of statements so that they can be run more than once. And they can also let us specify parameters that can serve as inputs to the functions. So you can remember the range function allowed us to put in parameters such as start, stop, and step size. So on a more fundamental level, the functions allow us to not have to repeatedly write the same code again and again. So if you remember back to that lesson with strings and lists, when we were using the function len to check the length of a string or of a list, if that's something you're going to want to do a lot, you're going to want to create a function so you don't have to repeatedly write out manually some sort of count for loop. Okay, and then finally these def or def statements. So def is a built-in keyword telling Python that you're about to create a function. And instead of going through the syntax here in a PowerPoint presentation, we're actually just going to hop in straight to the code and check out the full syntax. So let's go ahead and hop over to the Jupyter Notebook. Okay, so we're back at the Jupyter Notebook, and now we're going to go ahead and hop over to some live code to check out the syntax. So how do you build out a function in Python? So you first off start off with the def, the def keyword, and if you're using an IDE that highlights the correct syntax in Python, you should see it highlighted. And then you do a space, and then you enter the name of your function. And the rules as far as naming your functions are going to follow the same rules of naming variables. So I'm going to say name of function. So space, the name of your function, you can name this whatever you want, and then parentheses, colon, enter, and right now this is going to be a super simple function. It's just going to pass. It's not going to do anything. And that's your very first function. Okay, so now I can actually call this function. And if you're using Jupyter Notebooks, you can do tab to autocomplete. And I won't pass anything since it doesn't take any arguments. Shift enter and nothing will happen. Okay, so let's start building on top of this. So we began with that def, then a space, followed by the name of the function. And remember, we're trying to keep the names relevant. So for example, len is a good name for that length function. But you also want to be careful with names. You don't want to call a function the same name as a built-in function in Python. And if you go to the Jupyter Notebook, I actually have a link here that goes to all the built-in functions. So if you open this link, let me zoom in a little more so you guys can see it. Python has a bunch of built-in functions, such as the len function right here, length. And we'll be exploring these as we continue on throughout the course, but you want to avoid any of these names. So instance, like abs, all, any, base string, etc. Usually just make your function name more specific than it has to be, and you'll be unlikely to overwrite any of these built-in functions. Anyways, continuing on, we have our function, name of the function, then came a pair of parentheses, and that's where you're going to input arguments. And you'll separate the arguments with a comma. So you remember when we're using the range function, you inputted the start, the stop, and the step size, and they were separated by a comma. And then finally you have a colon there. And then you start a next line and you have to indent. So this indentation is actually important for Python, since Python makes use of what's called a white space to organize code. A lot of other programming languages don't do this, so keep that in mind, that this white space and this spacing and indentation is actually one of the most important parts of organizing your code in Python. Okay, so let's build up on top of this. Let's actually pass in some arguments, and I have to label them here. So I'm just going to label them arg1, arg2, and again, pass. I'm not going to do anything with those functions, or excuse me, with those arguments. And if I run that cell again, notice now I get an error, that the name of function takes exactly 2 arguments, and I'm giving it 0. So it's required now that I input 2 arguments. So if I input 1 and 2, I don't get an error, but again, nothing happens. So let's build out the function even more. we want to do something. So let's go ahead and rename this function. Let's call it my addition func. This is a really long name, but hopefully you can guess what we're going to do. We're going to say print arg1, arg2. Whoops. We want to print them being added together. And I'm going to get rid of that pass now since we actually want to do something with them. So now, if I run that cell to save that function, name a function, now I'm going to change this to my addition func. And notice how I use tab autocomplete for convenience there. And now if I run this cell, it actually takes in the arguments and does the code that's indented beneath the colon there. So something else you might see for functions is something called a docstring. So if you remember the range function, if I clicked Shift Tab, a docstring came out that had some information, range stop, list of integers. So you might be thinking, well, where's that information actually saved? So to create a docstring, you create a comment using triple quotation marks to enclose it. And then you say, here is whatever you want to say in your docstring, since this is just a giant string. Here's my docstring. I'm going to click Shift Enter to run. And now you'll notice if I click Shift Tab here, my docstring is actually recorded in Python. So if I call help on that function, that docstring is going to help you. So right now we're going to avoid docstrings just so our code is a little cleaner. But as your functions get more and more complex, docstrings are going to become increasingly important so you remember what a function actually does. Okay, so let's go ahead and get rid of that. And we're going to start off and back up a bit and start with a really simple example of a function. So let's go ahead and make a function called say underscore hello, parentheses, colon, indentation. And then all this is going to do is it's going to print hello. Now if I run say hello, I don't pass any arguments because it doesn't take any. It goes ahead and says hello. So now we're going to create a function that greets people with their name. So what do we want to do here? I want to say def space, and let's go ahead and make a function called greeting. And it's going to take one argument, and I can actually call the arguments whatever I want. Just like if you remember when you're iterating through a for loop, you can call those items whatever you want. I can call these arguments whatever I want. And I'm going to say def greeting name, and what I'm going to do is I'm going to print hello space, and then I'm going to concatenate or add on that name. And I should have used two double quotations, that's why that was being highlighted. Okay, so what is this going to do? It's a greeting function. I have def space greeting, and then it takes name as an input argument, colon, and the indented code is what's going to run once we call that function. So it's going to print hello and then plus name. So it's going to concatenate the string that we put into the name into the whole phrase. So I'm going to run that cell to save my function, and then I'm going to say def greeting, and let's just put in a string. I'm going to put in Jose. So I should expect hello Jose to come out. And notice I have invalid syntax. So what's going on here? Well, what's going on is I accidentally called def again. So remember, when you're calling your function, you just call the function name. You don't actually call def. Def is what you use to define your function when you're creating it. And then later on your code, you don't call def again. So that was just to throw that in there. So I'm actually just going to call greeting, just like we were using print hello. Greeting Jose, hello Jose is the output. Okay, so now we're going to introduce the return statement. So let's go ahead and see an example of using a return statement, and then we'll break it down a little further. And what return is going to allow us to do is return a result that can then be stored as a variable. or used in whatever manner the coder or you want. Okay, so let's head back and create an addition function again. I'm going to call it add num. And what it's going to do is it's going to take in two numbers. I'm going to call it num1 as an argument and num2 as an argument, colon. Click enter, my indentation is automatic, and now I'm going to introduce a keyword called return. And what return does is whatever is put in front of return, that's what your function is going to output. So remember, range outputted a list, and that's because it returns the list. So now I'm going to return num1 plus num2. So note, I am not printing the addition of these two numbers, I'm returning it. So now what happens is I can say x is equal to add num, and let's say we'll pass in the arguments 2 and 3. So 2 is that num1, 3 is that num2, and it's returning the sum of them. And now I can set that sum to a variable. So let's go ahead and run the cell, and if I call x now, it's going to be equal to that sum. I can also just say print that value, and it would work the same. Okay, excellent. So let's break it down a little further and ask ourselves, what happens if we were to input two strings into this function? So we have our add num, but remember, we're just specifying this with a plus sign. So if we were to put in two strings, let's say 1 and then 2, what it's going to return is 1 concatenated with 2, since they're strings. 1, 2. And I can even set that equal to a variable, and then if I print x, I get the concatenation of those two strings, basically them being stuck together. And why is that happening? It's because we don't declare variable types in Python. So if you're familiar with other languages, a lot of times you have to do something like call a var and declare the variable to be some sort of like integer, etc., etc. If you're learning Python as your first language, it's really nice because you don't have to worry about that. But one of the issues with that is for this kind of function, we could pass in strings and integers or floating point numbers, etc., and still get results out, maybe even if we didn't want that to happen. So later on, we're going to learn about adding in checks to make sure a user puts in the correct arguments into a function. So now we're also going to start using break, continue, and pass statements into our code. Remember that we introduced these during the while lecture, and now they're going to come back again. So let's go ahead and go over a full example of creating a function that checks if a number is prime. And this is kind of a common interview exercise, so we're going to head and go and break it down for you. So I'm going to clear this cell. I'll clear this cell as well, clear this one as well. Okay. So let's go ahead and start with def. That tells Python we're making a function. And I'm going to say is underscore prime. And there's my function. And I'm just going to say pass. So right now if I call it is prime, nothing happens. Okay, perfect. So let's start building on top of it. I want is prime to take in a number, right? Because we're going to take in a number and then check if it's prime. So save that, and now is prime is going to take an error or give out an error since it needs an argument there. So I'm going to go ahead and pass in a number, 2, and we don't get an error. Perfect. So now let's keep building out a little more. So we'll start with that docstring, which remember is the triple quotes way of writing a comment. And I'm going to say this is a quick description of this function. This function checks for prime numbers. That's one way of writing a docstring. Sometimes some people write docstrings with kind of this sort of format, and they'll label it input output so users know. Let me zoom in a bit for you guys so users know what's going to be inputted and outputted. So we know we're going to input a number, so I'm going to say input a number, and we are going to output a print statement whether or not the number is prime. Okay, so let's zoom back out real quick so you saw that. So now we have the stock string. I'm going to save it. Is prime with that 2, runs fine. And if I click Shift Tab, now my doc string is actually pretty clear. So input a number, output a print statement, whether or not that number is prime. Okay, so we're going to dive into math a little bit, but we know a number is prime if that number is only evenly divisible by 1 and itself. So what we're going to do is write a function to check all the numbers from 1 all the way to that number and then perform modulo checks. So I'm going to say for n in range, and let's start from 2 since we know 1 will always be go into a number. We can say from 2 to num. If the number we put in divided by any of the numbers from 2 all the way up to that number is equal to 0, then we know it's not prime. And then we're going to break out of this loop because we don't need to check anymore. And I'm going to head back 1. So let's say after we go through all those numbers, none of them had mod 0. That means no numbers from 2 all the way up to the input number go evenly into that number itself. Then I'm going to say else. So if mod never 0 occurred, whoops, I'm going to print the number is prime. Okay, now let's see if this works. Let's go ahead and input a number we know is prime, 13, okay, and now let's input a number that we know is not prime, 12. Perfect. So we know this is working. So there's other ways to do this exact same function, and there's actually better methods of checking for primes, and I'm going to kind of leave it to you as a homework assignment to go ahead and try to use either the math module to check or use your own Google abilities to check out what's a better method of checking for prime numbers. And just to give you a quick hint, if you scroll down to the bottom of this Jupyter notebook, their better version is example for you there. But let's go ahead and break down exactly what happened here so we understand all these various pieces that kind of really build out your first true function that brings in a lot of what we learned in the past together. So let's break this down completely. So we're checking if a number is prime. So I'm making a function using def to tell Python I'm about to make a function. I'm going to say is underscore prime is the name of my function, parentheses, num, that's the argument it takes in, colon. Then I have my doc string, which is basically a description of what's going on in the function. After that, notice all the code is indented at least 1 so it lines up with that name. That means all this code is going to run when I call that function. And now what I'm doing is I'm going for every n, which is going to be a number, from range 2 to num. And remember, since I'm in Python 2, I could have also done xrange to not create a list. If you're using Python 3, you can only use range, which is going to be the same thing as xrange in Python 2, but that's a small detail, don't worry about it. So I'm saying for n in range from 2 to that num. So what is that doing if I were to just to check it outside of the function? Let's say 2 to 12. It's creating a list of all the integers from 2 up to that num. Actually, up to but not including that num, which is important since we're checking for primes. And then I'm going to say if the number itself, so in this case if 12, divided by any of these numbers leaves you with a remainder of 0, then I know it's not prime, right? So if 12 is divisible by 3 evenly with no remainder, then I know it's not prime. Then I'm going to print not prime, and I'm going to break, which is going to break out of this for loop and ends my calculations. Else, if that never occurs, then I know the number is prime, and I'm going to print the number is prime. Okay, so that's our first lesson in functions, and functions is going to be something we come back to a lot during our code, and it's going to be one of the basic building blocks of our code, so you'll see it over again and again. So go ahead and check out the reading and this Jupyter notebook, and make sure you fully understand at least how to read and understand how a function is built out in Python. Okay, so thanks for watching this lecture, and I'll see you at the next one.